This is my latest creation, a control panel for a water treatment system in the Panhandle of Florida. It's an unusual event because I will not be the installer on this particular job. I'm only the designer and fabricator. This video is meant for the installer and for the end user so they can see the components, explanations of each, and a navigation display of all the screens to make their lives much easier in the future. This is the internal of the panel. Another slight oddity for one of my builds is to have a terminal strip located both top and bottom. The reason this job was done this way was because the original installation was done in such a manner that the wires crisscrossed the panel in a very haphazard, unprofessional manner. So I decided to add the terminal strip at the top so when my customer connects all of the wires external to this panel, it will still be in a neat professional manner for the end user. So we'll start at the components, we'll walk through them, and I will walk into the camera screen and point each of them out. Our top terminal strip here. I have my incoming voltage, a neutral bar, and these terminal strips are for the low flow pressure switches to verify pumps are indeed putting out water. The orange terminal is strictly for the external alarm light to the building. I have our Panduit. This is our booster pump control circuit breaker. This is our control circuit breaker, rather. And that control runs all of the 120 volts in the panel. And then we have our 24 volt DC circuit breaker, which powers up our DC power supply, which then powers up these three circuit breakers. One circuit breaker feeds my operator interface, otherwise known as the HMI. One of them is for future for a cellular modem or Ethernet, and the last one is for the fan. I will not be turning the fan on for very long just because of the noise generation. To the right of the fan, we have the thermostat, which senses the temperature in the cabinet and turns the fan on and off accordingly. I have 5 relays here, 1 contactor for the booster pump, my programmable logic controller, and the terminal strips at the bottom. Now you'll notice I use different colors on each of these, and again, some of this is because I won't be the installer and I want to make it as simple as possible for the person installing or the person that's doing the troubleshooting many years down the road. So the blue section of terminal strips here are all of my inputs and outputs to the 3 motors, well number 1 and the 2 high service pumps. The browns are for the 5 floats in the ground storage tank. The yellows are from the pressure switches that will control the high service pumps, and the black is for the booster pump output. Okay, we've powered the system up. You can see the screen as it's illuminated. Now, a couple things to note. I do not have any of the inputs or outputs connected to the system, so nothing will actuate. We will not get any alarms. We will not get any float actuation. We will not get any pump actuation other than putting the pump in hand. That will be it. I'm a very methodical person, so I like to move left to right, top to bottom. So we'll start in the upper left, and we have 2 push buttons. One says hour meter stored data, and the other one says settings. So we'll touch the hour meter stored data. That brings us up to a screen. The top row across, left to right, is the current hours for each of the pumps. Moving down from there is 1 day previous, adding each day down until you get to 7 days previous to today. Those numbers will move at midnight every night without fail. This is very helpful for the operator because if he doesn't have to write the numbers down, generally they do not. So he can look back and go, oh, I see high service pump number 1 has been running twice as many hours as high service pump number 2. It will give you an indication of an impeller that's starting to wear out or some other issue that you're not aware of during your plant visit. Now we can go, I'll go back to the home screen, and now we'll go to the settings screen. And there's a lot of data here, but it's really pretty straightforward. The top half of the screen are all of the discrete inputs, with the exception of the groundwater storage tank in service bit. We'll get to that in a second. So the lead pressure switch, lag pressure switch, the flow pressure switches in the middle, and the float switches on the right all have a green or red button next to them that either says green, normally open contact, or red, normally closed contact. Now, most of the time when PLCs are programmed, they are programmed for a specific contact type, whether it be normally open or normally closed. As somebody who has spent the last 2 decades in the field, I know that sometimes you have a normally open float and what you really need is a normally closed, and there's not a good way to make that work. Well, I made it simple on programming this one. It's a matter of changing the float out and then selecting the contact type that you have to match the system. So if you had a normally closed in service, it failed, and the only thing you had was a normally open, not a big deal. Put your normally open float in, come to the screen, change it over to normally open, and you're off and running. You don't need to order special floats, and you don't have to wait. That's a benefit. Now, the groundwater storage tank up at the top is a little bit different. That is nothing more than changing the control algorithm on how the wells and the high service pumps will behave. If the groundwater storage tank is removed from service to be cleaned, or because there is some other issue or some routine maintenance that needs to be done, then we will touch that and put it in bypass. Note, this button does not move any valves. It does not control any of the piping in the system. Those mechanical components will have to be configured manually by the operator, and then placing the system in the appropriate operational mode, whether it be groundwater storage tank in service or bypassed. Now at the bottom we have some failure modes and some timers. So on the left you'll see not in auto timers, low flow timers, and fail to run timers. And we move from left to right and you'll see high service pump 1, 2, wells 1 and 2, and the chlorine pump, and there is a number associated with each one. Each one of those numbers will bring up a keypad entry so you can change it. So we'll touch high service pump number 1, not in auto, and you'll see the numeric entry comes up. Comes up as a 0, and you can see on the screen that it gives you a maximum allowable of 10. There is no reason that it should take 10 minutes for the low flow or fail to run timers. Those should be on the order of fractions of a minute. The not in auto timer, if you're doing some control testing or system testing, you might want to have it out 2 or 3 minutes so it will not call for a pump. Not ideal, but I have been in situations where I've needed a little more time to work with a pump, and it's nice to have an easily adjustable time delay. Now, if I don't enter any value and I hit enter, I can have it at 0. That 0 value means that as soon as that pump is called for and it is not in auto, it will immediately fail. So what happens if you change that and you go, oh no, I don't remember what I should have it as? I put a restored timer value right here. And you see it went back to 1. 1 is a fairly liberal amount of time to work with. I would imagine that the times will actually be on the orders of 0.2 or 0.3 minutes at best for each of them. We'll get into how and what each of these failures go into when we get back into the main screen in a minute. So we'll do that now. Okay, now we're back on the main screen, and you'll notice that I have some images of pressure switches. 2 here, and then I have 2 more here and 2 more here. This system has a total of 6 pressure switches. The very top 2 pressure switches are the lead and lag pressure switches that control drinking water pressure to the people of Liberty County. The next 4 pressure switches are flow failure pressure switches. They are looking for enough water pressure upstream of the check valve to manipulate the pressure switch so the system has a mechanical feedback
knowing that there is indeed enough flow to warrant running that motor. We'll get to those a little bit more in detail in a second. We have our groundwater storage tank in the center, and you'll notice that I have a blue bar raising up on the side. Now, we do not have an analog input on this actually feeding back what storage tank is. What I am doing, if I touch this, it'll bring up a representation of the floats. You'll notice that each float is labeled on the right. The 2 alarm floats are labeled in red, and the middle 3, which will run the wells, are labeled in green. It's just a way of delineating which floats control the motors and which floats control alarm conditions. Now, the alarm float, if it tips up, obviously we have way too much water in the tank. We're about to put a lot on the ground. The off float will turn off both of the running wells if they're indeed running. The lead float, as it drops down, will call for the lead pump, the lead well, and the lag float, when it drops, will call for the non-running well. The high service pump cutout float, when it drops, what will happen is I don't have sufficient water in the tank, so I could have an air bubble induced in the line over to my high service pumps. In the middle of the night, if we had a condition such as that, it would be bad. We would lose pressure, and we would have a vapor locked or a pair of vapor locked high service pumps. Having system water pressure drop and having to do boil water notices and back tees is bad, but we don't want to compound that situation by having to vent off and clear vapor locked pumps at the same time. So that float switch is in there for that reason. Now, right now, for testing, I am simulating that the normally closed float is in good shape on the high service pump cutout. And you'll notice that the piping leaving the bottom of the tank and coming over to the 2 high service pumps is blue. If that switch drops down, then that piping internal will turn red to alert the operator that we have an issue. Now, you'll notice that we have a valve indicator here of a 3-way valve. That valve is not anywhere in the system mechanically. It is merely a representation of the realignment of how the system will function if the groundwater storage tank is put in bypass. Right now, the system is being shown to be in normal. The piping leaving the well motors and coming up is going over to the groundwater storage tank, and you notice that that port on the valve is now white, where the water coming out, or the pipe coming out of the storage tank, is blue, and the indication leaving the valve going to the high service pumps is also blue to tell you which way the water will flow. Now, you'll also notice, we'll go back to our flow pressure switches, that I have 4 of them here, but only 2 of them have green check marks. Those 2 are the feedback for their respective high service pumps. If high service pump number 1 here is running and this pressure switch does not open within the allotted time from the settings screen, it will produce an X. When it produces an X, the pump will fail, and the other pump, as long as it isn't automatic and ready, will start running. The other 2 pressure switches do a very similar function, but they do it for the wells when the system is in groundwater storage tank bypass mode. We'll cover more on that in a minute. Now, up above the high service pumps, you'll notice that we have an empty section of pipe. When our feedback from the soft starts for those 2 pumps is in the high state or on state, then that respective section of pipe will illuminate blue to let you know that the system is indeed seeing a feedback from that motor saying that the soft start is in the full run mode. If it does not receive that feedback signal within the allotted time per the setting screen, it will also cause a failure. Both pumps are identical in that control algorithm. As we move across the screen, you'll notice that we have a chlorine pump. That chlorine pump will come on either in manual or in automatic. In automatic, it comes on anytime either well 1 or well 2 is running and we're adding chlorine. We can put it in manual now, and all 5 of my handoff auto switches work the same way. If we touch the off, you notice my virtual indicator goes to off. And if we go to hand and I'm quiet, you'll hear the contactor pick up as soon as I touch the hand. There's my contactor. You'll notice that the green light, or green piping rather, is now fully green. So we are getting a feedback from contactor C1 stating that that pump is indeed working. Now, if the pump is disconnected externally to this control panel, then you will not be getting chlorine, but you will be getting indication as such. But that's outside the realm of this control project. We'll go ahead and put it back in auto now, and you'll notice it goes back to the same state. Now, right next to that virtual switch, you see a ready button. If I touch it one time, we get O period, O period, S period. That's my shorthand for out of service. If that pump is out of service, the system will ignore it even if it is in automatic because you are working on it. Now, a safety note. It is never good practice to work on a piece of equipment relying solely on a control switch, whether it is a physical switch or a virtual one like seen here. You should always shut off and tag out any source of electricity going to that piece of equipment before you work on it. Now we'll go ahead and put it back in ready. And there it is green. You'll notice the other 4, they all work exactly the same. Now, the only other thing on the right-hand side of the screen, and it really doesn't have a lot to do with the control algorithm, is you'll notice that we have a clock with a date and time on it. If I touch that date, I will bring up a input number pad where I can change the date and time, and then when I hit set date and time, it will enter. I can touch it again and it disappears. If I touch the groundwater storage tank, that pop-up window will also disappear. I like to have a lot of information available without completely cluttering the screen, so pop-up windows are an excellent method to do that. Now, working our way down to the bottom left, we have the high service pumps 1 and 2. Switches work exactly the same as the chlorine. And then we have the wells 1 and 2 with their respective controls and indications. Now, we will put the system in bypass. And you can see it says groundwater storage tank bypassed. And you notice that my valve has now changed position. It is now aligned to take water from the wells and deliver it right to the high service pump. You'll also notice that those pipes are an empty pipe. That is because there is not a well running at that point. Once a well begins to run, you will see blue go from that particular well, whether it's well number 1 or well number 2. It will go up to this valve, and the entire section of piping on this side will also turn blue. What you'll also notice is now my check marks are on the upper 2 flow pressure switches. So if we use well number 1 as an example, when well number 1 is called for and running, it's looking to make sure that those pressure switches change state, indicating that there is sufficient flow from that well. If there is insufficient flow, the well will fail and it will give you a low flow failure. That low flow failure will pop up over the well itself. It will also give you a failure reset button and a failure acknowledge button. If you do not know the cause of the failure, the immediate thing to do is to press acknowledge. Acknowledge merely turns off the light outside for the alarm. It keeps that pump in a failed state, and it allows the other pump to take up and run as the lead well or the lead service pump, respectively. if you hit reset without fixing the cause, it will fail again and you will be chasing your tail in a vicious circle. So press acknowledge, find and correct the cause, then press reset. Once you press reset, the failed indication, the reset, and the acknowledge buttons will be hidden away again. The high service pumps have a very similar failure, and they will also pop up over top of the motors with the same acknowledge and reset buttons. Okay, the only thing I haven't talked about is the hour meters that are on this screen. Now you can get them from the hour meter stored data. It's the very top row of data on that screen. But if you want to look at the current data for only high service pump number 1 and you still want to watch to see if well number 2 kicks on for some reason, you can go here and you can touch and it'll bring up the hour meter. And if you touch it again, hides it back away. All of my pop-up windows use the same methodology. It's a toggle on, toggle off method. So we'll go ahead and go back to settings and we'll change this back to in service and we'll go back to home. And you'll notice that my indication valve changed and my piping to my service pumps is now blue again. I hope this helps you in your operation of this panel. If there are any questions on the operations or how something is set up, you can see my number is on the panel above the touchscreen. I answer it 24/7. So give me a call if you can't figure out why a system is doing what it's doing or why it's not doing what it's supposed to be doing. I stand behind my work and I'm happy to answer any calls from anybody at any time. Thank you and have a good day.